Today we will discuss about post tension slabs for the buildings. See, before we talk about post tensions or PT slab construction, uh, let us discuss about pre-stressed concrete because post tension concrete is also one type of pre-stressed concrete. We know in RCC concrete and slabs get stressed when loaded, whether under its own dead load or combination of other loads. But in case of pre-stressed concrete can also be pre-stressed in compression by providing tensioned steel. It means this steel is already tensioned for the service loads, and then such pre-stressing or pre-tensioning of steel can be done by introducing stress into the concrete during construction process. So that is important that this introduction of the internal forces is during construction process to reduce the service loads. You can see this pre-stressed about the pre-stressed concrete. This has been taken from Wikipedia. See, number one, that is unstressed beam, and number two, if there is a loading, then their deflection will be down. So if we put steel, what is written as tendons, so if tendon is put in the beam and it is stressed, and then after initial stress, if it is left, then pre-stress forces will be developed in 4, and this will result in pre-stress deflection, that is deflection towards upper side. And when loads are applied, then this deflection will come down, so it will become flat. So this is the concept of pre-stressed concrete. Now these internal forces what we are talking are applied by tensioning high strength steel, normally called cables or tendons, and then pre-stressing of tendons can be done before placement of concrete or after. Now this, when pre-stressing is done before placement of concrete, it is called pre-tensioned concrete, and when it is done after placement of concrete, then it is called post-tensioned concrete. So this is the difference between pre-tensioned and post-tensioned concrete. In pre-tensioned concrete, pre-stressing is done before placement of concrete, and in post-tensioned concrete, pre-stressing of tendons is done after placement of concrete. Now, in pre-tensioned concrete, concrete is cast around steel tendons while they are under tension. The concrete bonds to the tendons as it cures, and when the tension is released, it is transferred to the concrete. Tension subsequently imposed on the concrete transferred directly to the tendons. Post-tension concrete, in pre-tension concrete elements, normally these are now prefabricated and they are transported to the site, like bridge structures also. So in buildings also, such members are prefabricated and transported to the site, and then pre-tension may be incorporated, and then we have the beams, lintels, floor slabs, piles, etc. in such category. Uh, in post-tension concrete, the tendons are not placed in direct contact with the concrete, but we provide sleeve or duct, what we call sleeve or duct. Inside of sleeve or duct, then the tendons are placed, or they are encapsulated, and when concrete has been cast and set, then tendons are stressed by pulling at the end. Then tendons encapsulated just sleeves and ducts, they may be of plastic or galvanized steel or similar material. Now there may be two types of cases when these sleeves or ducts, these may be grouted from inside, or they are not grouted at all, they are kept without grouting. So when internal grouting is done in the sleeves or ducts after stressing, the tendons, they are called bonded, bonded to because they get bonded to the surrounding concrete. So such post tensioning is called bonded post tensioning. And in case when tendons are left permanently debonded from the surrounding concrete, such post tensioning is called unbonded. In bonded concrete, you will see when concrete or grouts are there, then they also save the tendons from corrosion. So here also, in case of unbonded post tension concrete, this corrosion is prevented by greased or wax coating. So in case of unbonded post tension concrete, this greased or wax coated sheath is used over the tendons in such case. You can see that bonded post tension concrete upper figure, you will see one side it is dead end increase, another side is stressing increase, and then there is some you will see that a sleeve or duct is given some camber upside. So when it is stressed, then this will come down, and you can see here also in two figures similarly it has been done. So the one side it is dead anchorage, from the other side it is stress is applied for the anchoring. Unbonded case, you can see the sheath, and then this is not counted. And then the large force is required to tension the tendons, result in significant permanent compression being applied to the concrete once the tendon is locked off at the anchorage. So on one side this is to be locked off, and then some part where the concreting is done, a small portion concreting is done the last, so that concrete should be able to take up the load, and there should be no crack or no debondage with the tendons. So high performance concrete or high strength concrete is required at that. Advantages of PT slabs are many, like material savings. There is a reduction in the concrete due to thinner concrete members. There is a reduction in rebar and floor elements particularly, and reduction in dead load because they don't have they don't have beam, they don't have high thickness of the slab, so they result in the saving in dead load, and then dead load is less, so there is a result in saving in concrete and reinforcement of structural members including foundation. Then saving in building cladding because height can be reduced because of the higher headroom. Then vertical mechanical service elements, rebar, concrete, shear walls and other materials due to lesser sizes. And then construction is faster because potential force cycle is less. Then reduced seesawing requirement and coordination with embeds and MBP planes. Then this gives increased performance, particularly improved seismic behavior, reduced deflection and vibration. So including improved crack control and waterproofing properties, especially beneficial for parking garages and balconies. Longer spans and fewer columns give greater flexibility in floor layouts in offices and buildings, and better lighting in parking garages. Advantage is also there that in such case they give higher durability, and then they reduce lifetime cost because of lower maintenance and life cycle cost. Reduce building height, that is the important advantage, because beams are not there. So what is happening is that suppose the one building is there and then height is say 4.6 meter, and if the depth of the beam is say 0.6 to 0.9 meter, then effective headroom is not even 4 meters. If 0.6 meter is there, then 4 meter only headroom is available, and in case 0.9 meter depth is there, then it will be hardly 3.7 meter. So in such case of PT slabs, this height headroom is more, so we can have higher number of stories in same height. So that is the advantage, and it means reduced building height resulting to more headroom and energy saving. and even resulting in a higher number of stories. And then this can be considered as a potential for giving building norms also. This is PT slab and for ready for the construction in one of the site, you can see. Then this is after casting, you can see beams are not there even for higher spans. And you see another photographs. Then there are a few limitations, and grouting has to be proper to avoid corrosion in bonded PT slab construction. And it is to be ensured that there is no damage to pre-stressed tendons during life cycle of structure. Suppose you want to hang something during maintenance stage, and if you damage the tendon which is already pre-stressed, then there may be that may result its failure, and then accident may occur. So it has to be ensured that there is no damage to pre-stressed tendons during life cycle of structure. For that, you may have the notice board, even the signages in such buildings where PT slab has been casted, so that anybody who is coming and damaging or doing the holes in the slab uh, will be required to consult to the engineer in charge. Then only he will do it. It may be costly for short span structures, and specialized agencies are required to get up such works, and they may not be available at all the places, so that is the limitation. And after anchoring, high strength concrete is required at the ends, so hence arrangement for such concrete have also to be made. Well, thank you very much. I am KM Soni, a DG retired CPW. Thanks a lot.